I'll have to ask Nandini to come in. And I don't know what's happening with Aswath.
Srijit.
Solar Decathlon India, what's it all about? Net zero building, what's that all about?
Solar Decathlon India, what's it all about? Net zero building, what's that all about? Is it cool? Is it hot? Is it drool? Is it fat? What's that all about? Real world problems need innovative solutions. If you don't act now, there will be implications. Is it hot? Is it cool? Global warming would be cruel. You will form a team with the same desire. Going for the moonshot, forged by fire. We use technologies and crazy simulations. We learn to design with new innovations. So what you waiting for? No procrastination. Get off your butt, come join our workstation. Solar Decathlon India, what's it all about? Net zero building, what's that all about? These problems are tough and complex too. Your partners are there to help you get through. This challenge is exhausting, intense, it's a drill. These 10 mad contests will sharpen your skills. Net zero energy, water and stuff. And affordable too, that's crazy enough. Solar Decathlon and your heck it's really tough. But your attitude and grit is more than enough. Get your hands dirty on real world projects. You're gonna learn more than your specialized subjects. Solar Decathlon India, what's it all about? Net zero building, what's that all about? Cutting edge, butting edge, climate wedge, make a pledge. Do it all, save it for a lonely planet after all. Understand, climate friend, take a stand, make a trend. In the end, recommend your ideas will have defend. Are you hot? Are you cool? Are you gonna be a fool? Zero heroes are here to stay. So what you waiting for? Come join this play. Net zero building, that's what it's about. Solar Decathlon India, that's what it's about. SDI.
Solar Decathlon India, what's it all about? Net zero building, that's what it's about. Hello everyone, good morning. I am Amanda Taunausam, a member of the organizing team of Solar Decathlon India. I'm so thrilled to welcome you all to the Design Challenge Finals of 2022. As you know, Solar Decathlon India is a net zero building challenge, and college students develop market ready, resilient, and net zero building solutions. They do this for real building projects with real building owners as their partners. And today, the participants and their faculty mentors get to see what the jury members think of their work. Just 4 years ago, I was a finalist of the US Decathlon. And so I have been there and I know how the teams must be feeling right now. The flood of emotions that they will experience as they present to the jury and then waiting for the results, it's gonna be a complete different experience. I am also a jury coordinator for the on-site construction worker housing division, and I have seen some promising work by the teams and some really interesting discussions among the jury. This year, we have the communications contest. Our teams have been really active with their social media posts. Some of them, in fact, campaigned during the COP26 in November last year. Another high point for me is that Team Nivas 2.0 has done a song called Hum Zero Hai Kya. We have seen a lot of creativity in the past few months, and the next 2 days will be a time of discovery for all of us. We will get to see the work done by the participants in the last 9 months. We will get to see what they have learned and accomplished. Also, there are many companies that want to meet these finalist students and offer them internships. So, yeah, I'm really excited to see what our participants have come up with and who the winners of this year's challenge will be. Fingers crossed. Now, let me tell you about the agenda for the Design Challenge Finals. There are 3 things to note in the agenda. 1. Today, our 34 finalist teams will present their designs to the jury in 6 parallel sessions. 2. Tomorrow, we will get to hear the jury and we will see the winners and the runners-up of each division. And then, the winners in each division will pitch to our grand jury to get the grand prize. And 3, tomorrow, the the 430 plus finalist students get the chance to interact with leading companies working on climate action in our internship fair. They will have the opportunity to launch their careers to become our young leaders for net zero. These students are learning and exploring new technologies and approaches to building design. They are walking new paths and creating new paths for their partners. All of this is coming up. Today, feel free to switch through the division presentations and see the diversity of work done. And don't worry about missing anything. At the end of the day, you can see all the projects in the project exhibit hall, and the whole event will be on YouTube for repeat watch parties. Our virtual lobby has a quick network zone. You can make new connections and meet all friends there. So let's get going. Now we have a really cool guy for our keynote session. But before that, let's hear from Prasad, the director of Solar Decathlon India.
Good morning, everyone. Finalists, you are finally here at the finals event, and I hope you're ready to rock the audience. I wish you the best of luck. This Solar Decathlon India, what is it all about? And these net zero buildings, what are they all about? If you haven't figured that out yet, stick around for these 2 days and see what the students have done and what these industry experts, our 30 plus jury members, have to say about the entries. Most of our participants are working on net zero buildings for the first time. And that's exciting, and it will not be perfect, but I can assure you this: they have tried to do work that most experienced people in the industry rarely attempt to do. So stick around and poke around in their presentations. We have 6 divisions this year. Each division represents a building type and a unique net zero problem to solve. Solar Decathlon India is a tough challenge, not just because it's a net zero building challenge. It's tough because each team has to compete in all 10 contests with their market ready, affordable, resilient net zero building designs. So take a look at the entries and see how they've done on these 10 contests. This year, we started off with 99 teams from 109 colleges spread across India. They came from 23 states. They worked on projects located in 45 cities and towns. And now we have 34 teams in the finals. So many students and so many colleges with so many building owners. So is it cool or is it hot? Well, yeah, in the last few weeks, we have seen a heat wave rock large parts of India. And if we don't act to defend our population, there will be implications. The participants of Solar Decathlon India are proposing designs that will be our first defense against these climate change hazards. Their work shows resilient net zero solutions. And we have to move all our buildings in this direction. Can we use Solar Decathlon India to drive that change? Let's take these 2 days to appreciate and critique the work of the teams that have made it to the finals this year. And let's take a look at what's possible. So with that, back to you, Amanda.
Thank you, Prasad. Now let's get to Professor Ashwad Raman, our keynote speaker, who is joining us from the other side of the world, the University of California, Los Angeles. He works on material science and engineering and has done some killer work in radiative cooling. In fact, his TED Talk was the inspiration for the self-learning modules developed by Solar Decathlon India. Ashwad is a co-founder and chief scientific officer of SkyCool Systems, a startup on radiative cooling. In 2015, he was named one of the MIT Technology Review's Innovators Under 35. Today, he is going to tell us about his cool tech stuff and also about his journey as an innovator. Over to you, Professor Ashwad Raman.
Hi, everyone. Thanks for having me. So it's really my great pleasure to be here and to be able to share with you a little bit about my own journey in developing this technology that was mentioned in the introduction called radiative cooling. And so it's not only my journey as a scientist and an engineer, but also a bit as an entrepreneur as well. And so hopefully this will be of some interest. And I should say before I get going, congratulations, huge congratulations to all the finalists here, as well as your mentors and advisors. This is really a tremendous achievement, and you should all be proud to have gotten to this stage in the competition. So a little bit about myself. I was born in Mumbai, but very early in my life, I actually moved to Canada. And this, which was certainly an interesting transition for someone in a hot place. I grew up in one of the coldest places in the world, and it's kind of ironic that I ended up working on cooling technologies. And about an hour west of where I grew up in Calgary, which is in the Canadian prairies, there are the Rocky Mountains and some beautiful glaciers and places we would actually visit pretty often during the summer months. This in particular is a very famous one called the Athabasca Glacier that my family and I have had the good fortune of visiting many times. And what's very striking is that if we look at a picture of this glacier from about 100 years ago and compare it to one taken about 10 years ago, at the same time of the year, you can see something pretty striking. This glacier has receded, dramatically so. And in fact, within my lifetime, it may have receded all the way back to the top of the mountain. And we can in fact see that in our own family albums. And so from a very young age, I realized, even though I was in one of the coldest places in the world, the effect of global warming was very obvious. And so in my own journey to the position that I'm in now, as well as someone who thinks a lot about net zero buildings and technologies for net zero buildings, I began at a young age to appreciate that this was something that I cared about, but I didn't really know what to do about it. So I actually ended up doing a PhD. And so after I was a college student, I actually worked in industry in IT, of all things, for a year or two, but I decided I really wanted to do something about climate change, but I didn't know exactly what to do. And so I began, from my perspective as someone trained in physics and materials, to work on solar cells. So this is around the year 2007 or 2008. And I was very interested in how you can control light and how it interacts with materials. And in particular, how that could enable next generation solar cells that were much more efficient as well as cheaper. But as a graduate student, I began to learn about the real urgency of the challenge we face, which is something I think has become even clearer over the last few years. We, roughly speaking, have about 10, maybe 20 years to really try to start to bend this curve of our carbon emissions and to be able to reach the 1.5 degrees C target, or perhaps the 2 degrees C target. And as a student, I began to think very deeply about where did these carbon emissions come from? And unsurprisingly, I was thinking about electricity generation with respect to solar cells, but I also started thinking about cars, agriculture, and buildings. And when I landed at buildings, I realized my training in thinking about how light interacted with materials might have given me the opportunity to do something really interesting. As I neared the end of my PhD, I was really struggling. I was trying to figure out what I wanted to do with my career, my life. I knew I cared about these problems, but I didn't really know how to actually tackle them in a concrete way that could have a real impact. As luck would have it, or perhaps fate, a colleague and I came across some very unusual descriptions of a technology in the context of something people actually did hundreds of years ago to create ice, even without any electricity. And to introduce you to this concept, which I first came across almost 10 years ago, I want to show you these pictures. So these are pictures taken from a site, an archaeological site now, in the southwest of Iran. And the facilities that are shown here are collectively called Yakhchal, which in Farsi means ice house. And as the name would suggest, these facilities enabled people several hundred years ago, before the advent of electricity, to be able to generate ice in hot climates even when the air temperature was well above freezing. So you should ask yourself, how did people without electricity, and even though the air temperature might have been 5 or 10 degrees Celsius at night, even in the winter, how are they actually able to freeze water? You need to get down to 0 Celsius for that, right? Well, let's think about what that pool of water that's shown to the left is able to achieve. So typically, in the late evening hours, the people that operated these facilities would pour water into this flat, thin pool. And that pool of water would overnight freeze, even though that air temperature is only 5 degrees C. So what's going on with the pool of water? Well, it might be evaporatively cooling itself, and that certainly contributes it. But if you run the numbers, you'll see that that alone is not enough for that pool of water to freeze. How else is it able to cool down? Well, let's think about it from the perspective of that pool of water. It's actually looking up to the sky. Now, you may not think of the sky as a resource or a traditional resource, but it turns out it is. Because what's outside our sky is outer space. But wait a minute, we can't access outer space. It's really far away. Well, traditionally, we're thought to think about the exchange of heat in terms of convection and conduction. But heat can also be transmitted as light, in particular as infrared light, because we're at temperatures that are relatively cool, say around 20 degrees Celsius or even 10 degrees Celsius. So from the perspective of that flat pool of water, looking up to the sky, it is emitting its heat as what's known as thermal radiation, which can be visualized with thermal cameras that some of you may have used to imagine your own concepts and technologies to debug inefficiencies in buildings. So what happens? Well, that heat goes up to the sky. The sky blocks some of it. That's the greenhouse effect. But at certain wavelengths, in particular between 8 and 13 microns in what's called the long wave infrared part of the spectrum, the atmosphere actually allows some of that heat emitted as light to effectively transmit out. And what that means from the perspective of that pool of water in that ice house I showed you is that it's essentially able to radiate some of its heat out to space and thereby cool down to the freezing point. And it's able to do this entirely passively. So when I first came across this about 10 years ago, I was really amazed because I'd never heard of this, right? I was, a physics major and I was studying all these concepts and high-end research, but I'd never come across this concept, and it seems so simple. And it turns out people had actually pursued this idea for many decades. And so one of the most prominent demonstrations of this was by a very well-known French architect and building engineer named Félix Trombe, whose name is now assigned to the well-known Trombe wall, which is often used for passive solar homes. It turns out in the 60s, he was also exploring radiative cooling and demonstrated in a really heroic experiment that with a well-insulated box, a radiator that's shown right here at the center of a big insulated assembly could actually cool itself down to as much as 35 degrees Celsius below the ambient air temperature entirely passively. So what happened? Why wasn't this widely deployed as a technology? It seems amazing. No electricity input needed, and yet we're able to get to cool temperatures. So this seems like the perfect passive cooling technology. All you need to be able to do is put a surface outside to face the sky. Well, it was pursued by many architects and engineers, but in a sort of ad hoc and building by building kind of way. And one of the big limitations for radiative cooling as a technology in the 70s and 80s and into the 1990s was that it only worked at night. That Persian ice house only worked at night, for example, and every known demonstration of radiative cooling always happened at nighttime. But that's, of course, not when we need cooling the most. It's in the middle of the day that we'd want this kind of passive cooling ability the most. So why doesn't it work in the middle of the day? Well, it's the sun. The sun tends to heat everything up that's outside enough to counteract this cooling effect. And so this is where I realized we had something to contribute as scientists that thought about how materials interacted with both light and heat. And we applied for a grant. So this is as much a story of a technology as well as a story about my own personal journey. We applied for a grant from the US Department of Energy, and they gave us one of the smallest grants they'd ever given, this particular agency, because they were curious. They'd actually never heard of this concept either, and they were surprised. But they thought there was some potential in there, and they said, go ahead, try it out and see if you can make it work. But they only gave us 1 year of funding. So in that 1 year, I frantically worked along with my colleagues to come up with a material-based solution. And to summarize a lot of the sciencey part here, we basically came up with what you might think of as a composite or multi-layer optical thin film coating. And this kind of coating can be made with the same kind of technology that's used to make advanced window coatings these days. For example, low E or low emissivity glass coatings use the same kind of manufacturing process. But the design is very unusual. The design has two properties. One is it's very reflective over the solar spectrum. It's also very thin, each of these layers. But over infrared wavelengths, it targets the atmospheric window I showed you earlier and sends out heat where the atmosphere lets it out the best. And so to actually demonstrate it, I had to go out on a roof for the first time. I was not a building engineer. I was just a scientist who worked in the lab. But there was no other way to prove that it worked. And remarkably, when we put this outside and compared it to the air temperature, even though the sun was shining directly on the surface, it stayed as much as 5 degrees Celsius colder than the air temperature entirely passively. This was my own personal eureka moment. I was so curious whether it was working the first time I did this demonstration that I literally went on the roof and just touched it, and it felt quite cool to the touch. And that's when I knew this was working. And so again, this is a very counterintuitive idea. The notion that surfaces that are outside, exposed to both the sun and the sky, can be colder than the air temperature. So why does it work? Well, it works because we're basically reflecting almost all of the sun's energy while continuing to send that heat out as thermal radiation. So it's almost like we're basically allowing the surface to not get heated up at all and pretend it's nighttime. And when you do that, we now have something potentially really remarkable, a material-based solution to enabling passive cooling in the middle of the day during the hottest hours of the day when cooling matters the most. And so with that initial demonstration in hand, we went back to the Department of Energy and got a much larger grant to really prove this technology out. This particular agency wasn't just interested in more scientific papers. They wanted us to actually make this a real technology that could go out into the market. And so even though it was really early in the technology's development, I had to do something that was really uncomfortable for me. I had to go out into the real world and talk to potential customers of this technology. So I was talking to people that did cool roofs in industry, people that ran supermarkets, people that ran data centers, anyone that could use a cooling technology. And through all of that work of really talking to people in the field, hundreds of people in the field over one summer, we came up with the vision for what is now SkyCool Systems. And that vision was really structured by thinking about the cooling problem. The cooling problem today can be understood in terms of the massive electricity used for cooling, as well as the global greenhouse gas emissions that are attributable to cooling as well. And our company's motivation is really driven by the observation that cooling energy demand is expected to grow 6-fold by 2050, in large part driven by countries like India, where air conditioning and cold chain refrigeration prevalence are growing dramatically year over year. But we face a fundamental problem, which is that we cannot reach the 1.5 degrees C target for global warming if this happens. So technologies like ours clearly had a role to play. And so our vision, based on this macroscopic understanding of what cooling means as a business opportunity, as a climate change related challenge, but also from the perspective of the technology itself by talking to customers, was to actually use those materials we've developed and integrate them essentially with something that's not too dissimilar from a solar water heater, except our radiative cooling materials essentially cool water in an entirely closed fluid loop. And so this was actually our first generation that we tested in the field in 2017 in Northern California. And so here already we've scaled up from a small experiment to something that looks like a real potential technology. if we think about a traditional cooling system, a vapor compression cooling system, our vision was to actually have our panels, our fluid cooling panels, remove heat from a traditional vapor compression cycle after the condenser. In doing so, we do something called subcooling of the refrigerant. And when you subcool the refrigerant, you basically get more heat rejection capacity for the same amount of electricity that's being input into the compressor. And if you do that, you can get substantial electricity savings. And so this was the point at which we formed the company. So this is around 2016. And this was a very nerve-wracking moment for me because I had only been in a university and academic research setting my whole life. But we kind of dove in. And one thing we realized was that in the United States, as well as around the world, there's now a lot of resources. There's ecosystems of organizations such as the Solar Decathlon and other organizations sponsored by governments and companies that are really trying to help startups in this space find their footing. Our field trials, which are shown here, you can, in the zoomed out picture, see that our panels are hooked up to off-the-shelf air conditioners as well as refrigeration systems. Our field trials showed that we got as much as 15% electricity savings over a summer's worth of operation. So this was really encouraging. And from that, we were able to really build on that preliminary data to get both private investor support as well as substantial government support from different levels of government in the United States that have really allowed the company to scale up the technology at various points. So this includes funding from the state of California to support commercial pilots, as well as from the Department of Energy agency called ARPA-E to actually scale up the manufacturing and pilots of the systems in a lot of different applications, including data centers and supermarket refrigeration. And so here is actually one of our most recent commercial pilots in California in the United States. And so this is not a rendering. This is actually a real drone-based photo of one of SkyCool's recent deployments. And what you see here are an array of radiative cooling panels. And they are connected through a series of pipes thermally to a heat exchanger, which then cools refrigerant leaving this condenser unit of this supermarket type store. And so our first market is really these heavy users of cooling. So refrigeration in particular is a really intense electricity user. Even in cold climates, they have to run throughout the day and throughout the year. And so this, for us, represents what we think of as our first market. And so as you develop your own technologies, really think about who are the users that will want your technology or your concept the most. Who are the ones that are really going to be willing to pay for it? And who are the ones who are going to be the most excited and willing to take a risk on a new technology? That is, of course, one of the fundamental challenges we face in the sector we work in, which is that these are systems that are often important, they're critical. It's not software, it's something that's sitting outside and faces the elements. And so inherently, people working in this industry tend to be conservative as potential customers. And so you need to bring data, but you also need to show them why it will give a positive return on investment and a positive impact for the company in terms of its sustainability and carbon reduction goals. We've been able to collect a lot of compelling data in both using these panels to augment condensers, as I showed you earlier, as well as to potentially even replace condensers. And so, for example, here's the type of data that our company is now able to collect. We have actual real-world systems in the manner in less than 10 years. It's been extraordinarily exciting to see what had been a concept in something, stimulated by something I read in an academic article, actually go out in the real world, saving on the order of 100 kWh per day per one of these systems. And so with this kind of data in mind, we are very excited about the future for SkyCool systems. But beyond the company, as an academic, I remain really interested in what these kinds of passive cooling technologies could do and how we might be able to enable it with other kinds of material-based approaches. One concept we've been looking at UCLA in my research lab has been in making traditional paints, white paints in particular, super white or super reflective. That is to drive up their solar reflectance so high that they can also achieve radiative cooling and thereby become a compelling solution for applying to the outsides of building roofs. And so in a preliminary demonstration here, we showed a super white paint compared to the best in class commercial white paint that you can buy today. And we showed that the super white paint could stay colder than the air temperature on a roof-like setting, completely uninsulated, and as much as 5 degrees C colder than the best white paint you can buy, or best white coating you can buy on the market today. And this is driven by a postdoctoral researcher in my group. And in the academic article we published on this, we showed that there are actually a range of ways for us to push that reflectivity, that solar reflectivity of these kinds of paints, to as high as 99%. And so this is, I think, a very exciting kind of direction. There's still a lot of work to be done to actually commercialize this. But my hope is that this will actually allow us to think of going beyond traditional cool roof materials and view radiative cooling, passive cooling of roofs as kind of the future frontier of what next generation zero net energy buildings could do. And finally, to conclude, I want to point out that even though I've framed everything in terms of climate change and reducing carbon emissions, as was pointed out in the introduction, India and South Asia have been facing a really horrific heat wave over the last few weeks. And these kinds of heat waves have become increasingly common, even here in Los Angeles, where we've had temperatures as high as 48 degrees C in recent years, which was unthinkable until very recently. This is a problem for communities in the United States that are themselves underserved or low income. And for them, the heat, as much as the heat is a problem in South Asia, it can also be a problem here in the United States. And so we're, as an interdisciplinary effort, we are actually trying to take some of these concepts I've shown you earlier, not just to make buildings more efficient, but also to think about how we can allow cities to adapt to heat better. And this too is, for me, a completely new direction. And if I can leave you with one final message, as you think about your own future and how your work on the solar decathlon moves forward, remember that it's not just about any one technology, but it's about a way of thinking and a way of approaching the kinds of problems you're tackling, for they are indeed very important problems. Thank you so much for your time.
Thank you, Ashwat. That daytime radiative cooling thing is literally so cool. You have given us so much to think about. So, Prasad, do we have any questions from the audience for Ashwat?
Yeah, actually, we do have a couple of questions, and I'm glad to see the kinds of questions that the participants are asking, because they kind of reflect the work that they've been doing, the learning that they've had, and the thought process that they're having. So the first question, of course, is sort of trying to understand how this technology could be implemented or how it could be applied in, say, the Indian context. And the question is, in an urban environment where we have to be careful about, say, shading solar PV because of the buildings, does your cooling technology need similar considerations so that it needs to be placed where there is no shading and the sky can be seen?
So that's a great question. We generally are more tolerant of shading than solar, because the way to think about it is we're interacting with the whole hemisphere of the sky. So whereas the sun is in one point. So in fact, if you'll notice the picture I showed you earlier of that commercial pilot, it's in a part of the roof that that particular customer could not put solar because of shading issues. So basically, we're much more tolerant to shading. So in practice, I suspect what is going to happen is this kind of approach will probably complement solar on a typical roof by taking parts of a roof that are not suitable to solar for shading because of shading issues.
Okay, cool. Yeah, and so as you can see, whoever's asked this question is actually trying to think about how I can put this in a building and how it will work.
Yeah.
And the second question is sort of even more looking at implementation readiness or something, but it's how long do you think it will take for this technology to be launched in the Indian market, or are you already working on the Indian market?
We've done some tests in India. I can say that much. But I think it's, well, I mean, this is actually an interesting lesson. I think when we're still a relatively small company, it can be kind of challenging to operate internationally. India is international for us. So I think that's the hard part. But the opportunity is definitely there. The practical kind of considerations are how do you support customers, right? If you can, it's one thing to sell someone a product, but it's another thing to actually be able to provide them servicing and support if something's not working. So I think there's just those practical questions. Hopefully in the next few years, I think that's our hope, and working with partners as well on that.
Cool. Okay. Yeah, that's that's an important consideration, because it's the follow through that will make the technology successful, not just selling it.
Well, one thing I learned going around talking to people that have purchased new technologies is that at least in the US, I've found many buildings where there's defunct technologies sitting somewhere in a building that often either the company doesn't exist anymore, or they weren't able to maintain something properly, including for radiative cooling. In fact, there were many roof ponds that people used to implement. And most of those just were a maintenance nightmare, because it was a large tank of water on a roof. So
great. Well, thanks for that great talk. I'm going to turn it back over to Amanda now.
Thank you.
Thanks, Prasad. And Ashwat, thank you so much for inspiring our audience with your story. Best of luck to you, and we hope we can have you here again. Next, I am going to invite Dr. Nandini Kannan, the Executive Director of IUSSTF, to introduce the competition divisions and kick off the presentations. Over to you, Nandini. Nandini, we are unable to hear you. I think you're on mute.
Good morning. Thank you so much, Amanda. It's a real pleasure to join all of you this morning. The first thing I'd like to say is congratulations to all of you, not just the 34 teams who will be participating in today's finals, but to every single individual who's participated in the SDI Challenge. This includes over 1,300 students, the 190 faculty members, our industry partners, my colleagues from IIHS and AEEE, and every single volunteer who's made this program such a great success. Today and tomorrow, it may feel for some of the teams that others have done better than you, but I hope you'll take back an important lesson. The most important thing that Solar Decathlon has given you is this unique opportunity to learn, to innovate, to work as a team with individuals from different disciplines, to take on professional roles within this process, to really get to the heart of the problem you're trying to solve, and then, of course, to come together as one team to provide an innovative solution to net zero buildings. I hope this is a learning you will take forward for the rest of your lives. As you're aware, India has set a net zero goal for 2070, and the science suggests that we are going to have to achieve this even faster. And that's where every single one of you, by participating in Solar Decathlon India, is going to play a critical role in your future careers. 2 years ago, the Indo-US Science and Technology Forum embarked on this journey of SDI, signing a memorandum of understanding with the US Department of Energy, with our partners, the Indian Institute for Human Settlements, IIHS, and the Alliance for an Energy Efficient Economy, AEEE, as the implementing partners for SDI. Together, our goal is to help build capacity, build that next generation of innovative, talented building professionals who can really tackle climate change challenges. The 6 divisions of Solar Decathlon India focus on multiple problems in the building sector and provide solutions for thermal comfort and building healthy, resilient construction. There are 6 divisions. The multifamily and single-family housing divisions tackle the biggest growth areas in India's future. The office and educational building divisions focus on issues with the workplace. We have a construction worker housing division that focuses creative energies on designing safe, comfortable housing for the workers who will be building all the future real estate. And finally, last but not the least, Community Resilience Shelter Division recognizes that both in urban and rural areas, we need safe places in the event of disaster that affect individuals for short or sometimes even long periods of time. Today, we have a representative jury member from each of the divisions. Each jury member will talk to you about some highlights from their division, and maybe they'll convince you to go and attend the division presentations. I'll start off with the multifamily division. We have with us Mr. Dheeraj Wadhwa, who's director at Carrier Corporation. Dheeraj, what do you see as the highlights of the multifamily division? And again, I'll ask all our jury members to keep their remarks to a couple of minutes, please.
Thank you, Dr. Kannan, and good morning to everybody. I hope everybody can hear me.
Yes.
Okay. Interesting thing, if you look at this particular division, frankly speaking, the opportunity it gives is immense. One of the reports which I was reading through for 2021, it says about 2.3 lakh units per year is what either we construct or it gets sold in just 8 metros. And other than that, if you look at the Pradhan Mantri Awas Yojana, I mean, the potential is much, much bigger. So keeping all this in mind, when we went through the reports, what we had, it was probably one of those, I will say, divisions wherein the ideas were very different, immense, and something for us to become cognizant of the facts, coming out, new things coming out, new ideas coming out. And when you look at about 50 lakh people already given those Pradhan Mantri Awas Yojana residences, and then you connect the opportunity which lies for India's commitment for 2070, I think the net zero energy and net zero water becomes very, very critical for us. And when you look at the complete idea behind how we form the teams, it's a terrific idea. I mean, domain experts we have with us, we have the corporate, their experience levels coming in between and guiding the students. You have the faculty and the educationists with their knowledge and immense know-how of the technology and how the technicalities work. And then, of course, the passion what these students, the Gen Z, have. When they came out with new ideas, the net result overall, you will find some fantastic reports, some brilliant ideas, and just waiting for us to get them converted into projects. That's how I looked at the complete scenario snapshot. And of course, this division, I will encourage all of you to spend some time to go through the presentations the students have made. This is one of those divisions which got the maximum number of participation initially. I mean, if I may use the term, it was close to about 33% of the participation came only in this division. So please look forward to the presentations and the reports these students are excited to share with us, and we'll be glad to have you with us. Thank you.
Thank you so much, Dheeraj. Sounds really exciting. From the single family division, we have with us Sashwati Chetia, who is an associate director at Green Tech Knowledge Solutions. Sashwati, any interesting highlights from your division that you could share with the audience and sort of maybe encourage them to go visit?
Yeah, thanks, Nandini. So I'm glad I'm following the multifamily homes because, that is there in some of the bigger cities, but there's a lot of smaller pockets of single family homes being built, especially in the, tier 2, tier 3 cities. And we need to give the benefit of efficient, thermally comfortable and resilient designs to these millions of homeowners. And it is important because these are, independent owners who are, maybe designing their own buildings, and also they are going to occupy them at the same time. So it's important to get them, get these buildings also to the net zero level. And single family homes have the best potential, I think, to go net zero energy wise as well as water, and also make a visible impact in terms of the complete scale of buildings or the amount of buildings that are going to be built. And in the entries that I reviewed, teams have shown exactly how you can go about doing this with the design measures that first reduce your energy and your water demand, your demand for resources, which can then be fulfilled by these same resources generated right on site. And all of this while being keeping an eye on affordability and taking care of future concerns of climate resilience. And some of the highlights that I can talk to you about is looking at what the building itself can do, how it is designed. And there have been some very innovative ways to construct the building envelope itself, the roof, the wall, shading, using local materials and also traditional yet still new materials and finishes. And there has been use of design elements in the building that can help with cooling, and in one of the designs with heating as well, since it was in the cold climate. And they have also addressed resilience problems, climate resilience issues, very specific to their context, very specific to their location, which would be a concern going into the future. And all of this then supplemented with generating energy using renewable resources that are easily available right on site. So all of this has been showcased in the single family division. And I encourage all of you to watch the presentations in this division, because there are some really, really cool and innovative ideas here.
Great. Thank you so much, Saswati. You sort of addressed some of the really challenging problems, right? To take affordability and yet have a design that's aesthetically pleasing. So kudos to the team, and I'm sure we'll have a lot of visitors to the single family division. From the Educational Building Division, we have with us Harsh Thapar, the founder of Envirolizer. Harsh, you are a second-time jury member in this division, so we'd love to hear your thoughts about the highlights from your division. What can you share with us today?
So, Nandini, thank you very much for introducing me and giving me the stage. Yes, it's been a 2-year-long, very exciting journey. I think I would love to say here that when I was studying in a university and then working as a young architect, I was always fascinated with competitions like SDI, Special Solar Decathlon India, and the amazing amount of learning they can achieve in a short period of time. So firstly, I'm delighted and proud to be here. And I chose deliberately to judge the educational division because I really firmly believe that, this building type has a chance of a great impact, in terms of the real life learning that can be created on education buildings. So there is a special place for education buildings in Solar Decathlon India. And especially because it's actually the students reimagining learning environments for students like themselves. So in the broad context of COP26, of course, there is a great emphasis for schools to decarbonize. And also there is an emphasis on developing new curricula to support net zero learning. In India, specifically, there is great need for clearer policy development for net zero educational buildings. So I firmly believe that this competition and the entries will give a lot of great ideas to anybody looking to take them for future policy development. And I'll just share some quick highlights of what people attending it can expect today. So there are 7 student teams, amazing teams in the finals. So this is the largest number of finalists for any division out of the 6. It's going to be a tough competition and an exciting day ahead. The projects are of varied types. So they're ranging from regular schools, junior, middle, high school types to specialist institutes like medical colleges. And they are located in different climate types. So from temperate, warm, humid to cold climate. So there is an amazing lot of learning that can be had today from these projects. Since these projects are actually live projects and many teams have made great efforts to closely interact with industry partners, client teams, I think there are some trends anybody carefully watching these projects can actually glean regarding the future of energy efficiency in educational institutes in India. So, for example, I think there is a great effort to understand comfort and challenge established norms on this topic. There is a lot of the projects demand a lot from passive architecture, and that's amazing as an architect. There is bold, innovative exploration of low energy active cooling systems by students. And very importantly, I think you should watch out for the role of this important building type as it's explored in context of the larger community in which it sits, so its interaction with the community. So I encourage you all to please come and join these presentations, encourage the students who are creating the future of energy efficient educational buildings in India. Thank you very much.
Thank you so much, Harsh. You've made a passionate case for folks to come visit the division. From the office building division, we have Gyan Modgil, the founder of Sterling India. Gyan, you are also a second-time jury member in this division. Can you give us a quick preview of the projects in your division today and your thoughts?
Thank you, Nandini. This is a very good initiative which is started by SDI. I would like to congratulate them for this. And this is the initiative which promotes the talent and bring out the creativity of the young architects and engineers. We are all getting back to offices after this pandemic, and office spaces are known as energy guzzlers. And once again, those are going to see the same. In India, we have National Building Code NBC 2016, which has got chapter on sustainability. This chapter covers siting, form, design, envelope optimization, materials, water, waste management, building services optimization and commissioning, operation maintenance, and all building performance tracking also is covered. This chapter similarly describes the design strategies as per the climate zones for various seasons and gives the three approach like ECBC gives. So NBC also has a chapter on asset and facility management this time, which is an important factor for operational performance of these buildings. Now, we also have Energy Conservation Building Code, ECBC, for commercial buildings. This need to be followed by all buildings which have to go through EIA clearance, that we know. But ECBC do describe requirements to reduce energy consumption through envelope optimization, comfort systems, lighting, renewal, and is customized for climate variations and occupancy levels. But not very many offices constructed in India follow ECBC standards. That's all we know. From the reports I reviewed, I was thrilled to see entries that have attempted to go beyond ECBC standards and tried to achieve net zero. Some ideas that were interesting to me were consideration towards low embodied energy, recyclable materials, amalgamation of passive and active strategies, low energy HVAC systems, water conservation through reuse and recycle with low energy effluent treatment. And the show which they have the exhibited talent towards resiliency and all, and health and safety, that was also remarkable, which was shown by the young teams. I encourage you all to come watch the presentation in office building division to find out how these students are transforming the office buildings of today. Thank you.
Thank you so much, Gyan. From the on-site construction worker housing division, we have with us Mr. Isaac Emmanuel, who's head of innovation management and strategic alliances at Covestra India. Isaac, what do you see as some of the highlights from your division?
Thank you very much, Nandini. I hope you can hear me. Yeah.
Yes.
So to me personally, I come from Covestro, and we have an inclusive business which basically looks at the underserved communities. So it was very, very, very good for me that I could actually be in this particular division, where we know that there are millions of Indian workers who are living in abysmally unsafe and unhygienic environments, and leave alone the aspect of comfort. Right. So I really congratulate SDI that they have taken up this division this year. It's path breaking. It's also a trend bending, because we are looking at people much more than anything else. So I would really say that in India, even though we have way back in 1996 the Building and Other Construction Workers Act that mandates proper shelter, respectable shelter to workers. Is it really happening? The construction workers should be provided with proper shelter. But is that really happening? No. Every day you see situations which are so detrimental, and especially women who become the victims of such poor conditions. And I was really happy to see the passion even in the reports. I mean, we are yet to hear them, but it's really a wonderful site that they could actually get into certain aspects of collapsible structures, working with as small as 150 workers, even up to 800 or 1,000 workers in a site, and thinking also of recycled materials, recycled plastics, natural materials like agro waste boards. So I really see that uh, need for such semi-permanent structures with the right materials and with the right structural elements. So there are brilliant ideas, there are brilliant solutions, and six teams of them, and they really have taken a lot of effort and also working collaboratively and bringing the people aspect in a very forefront manner. So I encourage all to come watch the presentations, watch the interactions for the on-site construction workers division, housing division, because there's some really, really good stuff there. And remember, it's the only division that also requires zero waste in construction. So I'm really looking forward, as you all must be too. Thank you so much.
Thank you so much, Isaac. It sounds fascinating, and again, we encourage the audience to pick their favorite divisions. And finally, we have the Community Resilience Shelter Division. We have with us Anamika Prasad, who's Director, Environmental Design Solutions. Anamika, you are also a second-time jury member. How was it this time, and what highlights can you share from your division?
Thank you, Nandini. Good morning, all. As you pointed out, this is my second time as jury for the Community Resilience Shelter Division. And I'm proud that student teams are tackling this complex design problem with goals for net zero performance. In India, disaster resilience is taken care of by the National Disaster Management Authority through mitigation, response, recovery, and reconstruction. Having reviewed the entries in this division, I can confidently say that most teams will significantly contribute to further strengthening NDMA's efforts. Through their approach, the student teams have started establishing the importance of preemptive risk reduction over post-factum response. 2 years in a row, it has been very satisfying to note that all teams have, transcended their site boundaries and tried to engage with the vulnerable communities they are catering to. So join me for captivating presentations that deal with building materials as diverse as ICRA reed walls, Zerin bricks, corrugated bamboo roofs, hipped bricks, mud, rice husk, and cow dung, systems like square foot gardening and bamboo charcoal filters, structural solutions like wed flood proofing and well ring foundations, energy generation through kinetic sculptures, PERC solar panels, MPP tracking algorithms, flow batteries in electromagnetic paving, and finally, resilience measures that involve e-governance, cattle accommodation, and seed banks. All this while tiding over cyclones, sea floods, river floods, soil erosion, earthquakes, and vector and waterborne diseases. All this through a process that is collaborative, innovative, and sustainable. I'm breathless, but there's more. The presentations will take you to exotic sites situated in Ullal, Lakhimpur, Pentakatha, Golaghat. Clearly, the mundane humdrum of metros is not for us. With that, I invite you to come watch the presentations in the Community Resilient Shelter Division, a division that I'm very proud of. Thank you.
Thank you so much, Anamika, and thank you to all our jury members for really inspiring, giving us a teaser of what's to come. And I think, I know I've picked my division that I'm going to go visit, and I hope everybody in the audience has done that as well. So now, with no further delay, let's go watch the presentations. To do that, you will need to exit this virtual hall and go back and into the division hall. So see you there soon, and thank you again for joining us this morning.